We all know that stainless steel parts are ubiquitous in our lives. It can be said that stainless steel parts are closely related to our lives. Hello everyone, welcome to watch this video about stainless steel materials and stainless steel parts processing. If you are also interested, you can subscribe to and follow us. Stainless steel is the abbreviation for stainless steel and acid-resistant steel. Steel that is resistant to weak corrosive media such as air, steam, water, or has rust resistance is called stainless steel. So, what are the classifications for CNC machining of stainless steel parts? Stainless steel used as CNC machining materials is usually divided into martensitic steel, ferritic steel, austenitic steel, austenitic ferrite steel, precipitation hardened stainless steel. They are obtained by adding elements such as nickel, manganese, and nitrogen. The chromium content usually varies between 16% and 26%. The carbon content ranges from 0.03 to 0.08%. Chromium provides some antioxidant properties. Basic stainless steel alloys are divided into ferrite or martensite. Ferritic alloys with a chromium content of 10 to 12% cannot be quenched. Martensitic alloys have higher chromium and carbon content, as well as manganese and silicon content than ferritic stainless steel, so this alloy can be tempered through heat treatment. The corrosion resistance of martensitic and ferritic stainless steel alloys is basically chemical, so the processing difficulty of these alloys is not much more difficult than that of ordinary steel. Adding nickel and other elements to austenitic stainless steel can result in higher hardness, toughness, deformation resistance, and thermal performance, thereby reducing machinability. Precipitation hardened stainless steel. When it is necessary to combine high mechanical properties, good corrosion resistance, and good machinability, this series provides an alternative to austenitic stainless steel. Its main characteristic is good corrosion resistance, good weldability. They are magnetic, achieving very high mechanical strength through heat aging treatment and hardening. Even at high temperatures, they can maintain high mechanical resistance. The best and fastest way to manufacture stainless steel parts is through CNC machining, especially CNC milling. Tool manufacturers believe that due to the higher strength of the alloy, the mechanical cutting force will be higher, so stronger negative geometry tools must be used, which will reduce cutting parameters. However, this method produces tools with short lifespan, long chips, frequent burrs, unsatisfactory surface roughness, and unwanted vibrations. In fact, the mechanical cutting force generated by austenitic stainless steel is not much greater than the mechanical cutting force commonly used when processing traditional steel. Most of the additional energy consumption required for processing austenitic stainless steel is a result of its thermal performance. Processing is a deformation process that generates excessive heat during processing of strain-resistant austenitic stainless steel. I share a few key knowledge points about tool selection and machining parameter optimization when manufacturing stainless steel parts and processing other advanced alloys, which can help manufacturers achieve efficient and stable production. 1. Selection of cutting parameters. The most effective method is to use the maximum cutting depth and feed, aiming to maximize the heat removal from the chip. The poor thermal conductivity of stainless steel means the generation of longer and larger chips, which can take away more heat and reduce the number of cuts, reducing the trend of material warping or hardening. 2. Application of refrigerant. High-quality coolant, especially water/oil lotion, plays a vital role. The use of high-pressure coolant is more effective, and some technologies can directly apply high-pressure coolant to the cutting area. 3. Coating and tool wear. Hard coatings can improve the thermal hardness of cutting tools, but coating design needs to consider coating thickness and adhesion. Coatings can prevent adhesive wear, provide lubricity, and increase cutting speed to help reduce the mechanism of tool wear. 4. Specific geometric shape of specific materials. The geometric shape of the cutting tool has a significant impact on the machining effect. For different processing requirements, tool manufacturers will design specific tool shapes to achieve a balance between sharp edges and rigidity, providing high productivity and process reliability. The above is all the content I want to share in this video. If you are interested in topics related to stainless steel materials, you can follow and subscribe to my channel.